Thanks for coming to my talk today. I'm going to talk about a modern database interface for C++. My name's Erik Smith. So first off, why do we care? I'm going to try and boil this down to just 2 data points. There are a lot of reasons why we might care about this that are probably pretty obvious, but I'll just put these 2 data points. So if you think of a database like SQLite, SQLite is installed on every smartphone in the world. I tried to Google what that number is, but I have to think it's in the billions at this point. So databases literally are everywhere. And I'm sure probably everybody in this room has probably encountered a database, if not on every project, at least on many of them. So they really are everywhere. A second data point is has to do with JDBC. And this talk very much is about that layer of the stack, which I'll get into in a moment. JDBC was introduced in 1998. And I think a large part of the success of Java in its domain has to do with the fact that you get that connectivity very easily. And here it is, 2016, and we do not have a standard interface. It's not that we don't build databases with C++, it just isn't something the standard doesn't help us at all here. So I did not name this talk a standard database for C++ because I think it's going to take quite a bit of time to get a standard pushed through, so I'm just going to call it a modern interface. I just want to acknowledge some previous proposal work in this area by these individuals, and I have read them, and there were points from each of these that I have taken, so credit to them. So just a little bit of a primer here for those who may not be familiar with this. This is just a quick picture of the relational model. This is the type of structured data that you get out of a database, and it's really straightforward. You just have columns that define a data type per column and the rows. So this is a type of structured information stored in the database. It's also the same structure that you get back from the client APIs as well. So this is the type of data that this interface is designed to work with. The second item below that is an example of a SQL query, which I'm sure no doubt probably all of you have worked with. This is an example of a text query that you use to pull data out of a database. And for the purposes of the interface which I'm going to show today, I'm going to call this a ROWSET, just because that's how I've named it. So let's take a look at the client stack for this for a moment. The areas in blue are really the areas I'm focused on, and I want to talk about what the focus of this project is and what it is not. So I know that there's a lot of existing work. One particular project, there are a couple projects that are focused at a higher layer of the stack, in addition to the layer I'm focus on, which is like Roland's CPP project. I'm focusing on the driver layer itself. And I think the main reason for this is I think this is a really necessary foundational layer for other types of interesting work to be built on top of. And there's just a lot of details to get right in this layer. So it's really a project in and of itself. Just to describe a little bit of detail on this stack, you've got application code, which can either be built directly on top of this interface, like it is in cases with JDBC, or you can have an ecosystem on top of this layer, which is where other things can be built. Things just like straight database utility code on top of it, lightweight query builders, or full-blown ORM frameworks can exist on top of this layer. Now, as far as the layer itself, I'm going to describe later in the talk the design of this layer, because there is a front-end layer which is intended for people writing user code, and then there's a driver layer in which where you'd be interested in that if you were implementing a particular database driver. And then on the bottom, we just have the client interfaces for the various database drivers. Sometimes they're written against those interfaces. Sometimes they're written against just plain sockets. If the protocol for the database is known, there's other options for the future. such as fibers and coroutines. So just to get into it in detail here, I'm going to show you an example of what this is. And the code has been, this is not just, this is code that I have that's working. So I've given the examples in this talk a bit of time to ensure that this is actually a workable interface, although there's plenty of work to be done. But this needs to be an easy to use interface first and foremost. So I hope that what this conveys is that it's a pretty easy interface to use. I don't want to sacrifice any functionality in favor of that, but we'll get into the functionality as we go through the talk. So a couple things to notice here. There's no explicit types mentioned here. So this is using the chained call style, which I'll talk about in a minute, but I think this lends to a very succinct and compact style. Now, a few other details to that example that I want to throw in here is that you would have to have an include, and you would want to alias a namespace. So when I talk about this being a standards candidate, I don't think we're ever going to see actual drivers in the vendor implementations. That doesn't seem likely to me. So the idea here is you'd want it to seem as uniform as possible. So the way you can do this is including a header for your particular implementation, which may or may be provided by the compiler, but I don't think so. And then just create an alias, namespace alias, so that you have consistency among your interface. If you want to switch vendors, you can do that. When I say vendors, I really mean open source efforts. And that's what this is. This particular effort is a reference implementation for the interface I'm proposing. So with that addition, you have a fully working example. So a little more on this style of interface. This is a composable interface. It's using a classic method chaining approach, which has really been around for a long time. And I'm not sure if everybody likes this, but I think it's completely appropriate for this particular model. And I think it has a little recent support added to it with some of the proposals for uniform function call syntax. So that would suggest that there are people on the committee who like this style and want to promote it with this kind of work. Now this hasn't made it in the standard, but Jardim himself has supported that proposal. So, and that's a proposal where if a method call fails to resolve, it will call a non-member function. So you can retain the chaining call and not have to have everything be a member function, although most of the ones in this core interface are. One thing I should mention here is that all of the examples here until later in the talk are direct interfaces. By that I mean that most people, when they implement a database, are just coding against one database. And if that's all you're doing, you should be able to do that without going through extra layers of indirection. And that's supported by this driver. You can either say, I'm only using MySQL or only using SQLite, or as we'll see later in the talk, you can access a poly interface, which is the exact same interface, but allows you to resolve to a particular driver at runtime. So let's look at the various types in this interface, and these should be pretty familiar to anybody who has used any type of other library. They're all fairly similar in the types they declare. And database interfaces are all about managing resources. So each one of these is paired with a resource that needs to be managed on the client layer. So just going through these pretty quickly, you've got the database, which is a top-level context. The connection maintains a connection to the server. And these are all REII-type interfaces. Statement for query execution. Primarily, statement not only manages things behind the scenes, but if you need prepared statements, that's why you'll need a statement. Column set is for metadata for columns. A column is a specific metadata for a column, or metadata for a specific column. The row set, that's the primary data structure in this API that is probably most important here. A row accessor is just a particular row within that row set, and field. Now these last two objects are proxies, and we're gonna get into that, what that means. So just to break this out a little bit more so you can see the types more clearly, this is the same example, but just in a more classic form, a non-chained form, where you can see each of the individual types in action here. You're still not having to refer to the types, but in this case, you can see it broken out. You can see clearly the database being connected to, or the database being created, then the connection, then the query, then the rows, and then just a more C++98 style of for loop. A little bit about the methods here. So I think I've actually have two styles here. One is what I'll call it by type name, and this is where the accessors on these class are just analogous to the types themselves. So if you want a connection object, the name of that accessor is just connection, versus a natural style, which is more like a noun or a verb, where you say connect, query, rows. I prefer the natural style, but I can see use cases for both, so they're both in the interface at this point. Now maybe somebody will come along at some point, you must choose between one or the other, but nothing here standardized. So I'm keeping options open here just by having both of these available. This interface should be flexible. So all of these statements are equivalent. So one of the things I mentioned is this design has a front end layer and a driver layer. The front end is common to everything and is not anything anybody needs to extend. The driver layer is where the extension is done. So because of that design, it's easy to achieve this. What I mean by this is that if you want to query something, you can do it from the database, you can do it from the statement, you can do it from the connection. All of these are okay. So this leads to a flexible style in which whatever object you happen to have at the time, if you want to do a particular operation that makes sense, you can do that. And it's hard to get wrong. Okay, so one of the things I should mention here is all of these objects are what I call reference types. And what I mean by that is they're all holding standard shared pointer to internal data. Now this, if you've tried to hand roll your interfaces before, you may not have seen this detail. You don't actually need that if all your examples, such as the ones that we've seen on the previous slides, are all nested within the same scope. There's no need to have a smart pointer in this context. But as soon as you get to a use case where you have let's say, some type of utility function where you want to pass in some user data and you want to get a ROWSET out of that, now it makes total sense why these should be reference types that are that use shared pointer. And the reason here is that you'll notice inside of this utility function, I'm creating a database context and implicitly getting a connection via this query accessor, and then I get the ROWSET as well. And unfortunately, I'm missing a return statement in there, but there should be right at the DB line. This is going to return a result. There's nothing wrong with this. It's safe to do this because the ROWSET is going to hold the state information it needs until it goes out of scope. So this would be the kind of thing you would do when you reach a certain design level in your application. You'd want to design for this. So therefore, they hold reference types. And I don't think that impacts the performance at all. However, there's also a policy capability in the API. If you really care about that, you can specify a policy not to do that. Okay. So I'm going to go through a little more detail on each of these layers to give you an idea about what they're supposed to do. And these are just some examples. The database is a top-level object, and it's a context object. In some cases, it manages resources for the driver. In some cases, there are no resources to manage depending on the database driver. But it does things like get connections. If you specify at the database layer a URI, then when you ask for connections, you do not have to specify it. It has a notion of a default URI, which just makes it convenient in your code to not have to litter your code with a bunch of connection strings everywhere. It also has there's a difference between connection and create connection. Most of the time, you just want a connection, but there are some contexts in the presence of connection pooling where you want to actually ask for another connection, not the same one handed to you based on your thread ID. So that's what creates connection for, and we'll see an example for that in the talk. So that's what this does. But as I mentioned before, if your use case is simple, in fact, if you're executing queries that don't return results, you should be able to just execute that query straight from the database object, and you can do that. A little bit on connection strings. It's just using a URI syntax. This is something I've seen done in other database drivers, and it seems very reasonable to do this. You just have the name of the driver at the top, like in a URI syntax, // the server, the DB, and some of these details will be specific to the driver, but there is some overlap between all the drivers that would make sense. You can also specify a name source, and this is just an extension mechanism in the framework to say, hey, I want to name my sources and I want those sources to be looked up in a config file. And rather than specify exactly what that should be, that's simply a hook you can extend for if you wanted to look for some, any format in some location within your application or in your home directory. All of that's possible through an extension, and that's through a custom resolver. Connection. Connection is where there's two things you can do here, and this is true for the API. If at any point you have an object and you want to get the parent object, that's always a possibility. So if you were handed a connection, you need to get the database, just say .database. The other thing that's primary responsibility of a connection is transactions. So there's a bunch of transaction calls here that you would expect if you're familiar with how transactions work in a database, ability to start a transaction, do a set of operations, and then commit them, checkpoint them, or roll them back. This is something that you can do if you have a feature called scope exit, and this is not in the language, so I'll only mention it briefly, but there is a proposal to add this, and this just allows the ability to define a scope within your function that causes the statements within the scope to be executed upon failure. So again, this is a really nice thing I'd like to see added in the language, and you'll see that in a couple slides of the talks of things that I think need to be there that would be great. This drastically simplifies complex transactions in which you have to manage state carefully. The statement object. This is primarily, again, needed for prepared statements, and I'll have an example of this a little bit later, but essentially a prepared statement is when you're going to execute the same statement repeatedly, and you want to save the work of having your driver layer or database to have to repeatedly parse the query. You want to do this outside of the loop of your program at a higher level. Say, please prepare this query, and then you use statement.execute to pass it parameters, and these parameters correspond to the question marks. So the work of preparing the query is done front, and then you pass parameters, and that can be a big performance improvement. So that's a primary role of the statement object. Okay, now we get to the row set. So the minor accessors in this row set are things like row.width, which would just be the number of columns. If it's a useful thing if you're trying to loop over it. Row.columns returns column metadata so that you can get the names of the columns. Row.length is the number of rows in your results set. And this would only be defined if you actually read all of the results or if you had some type of mechanism that was materializing them up front. But I still have it in here just to have a general notion of what a row set can do. So the big question here is, what about row traversal? And this is a really important aspect of the API, is how are you going to iterate over the data? And there's a couple approaches that have traditionally been done that are in existing libraries. Things like next and done, where you say, give me the next row, check to see if there are any left. So I've got a couple of options here. The front pop-up, front and empty are a notion of ranges that you may see in other languages. Well, in C++ we have iterators. So why not iterators? Well, this is what we use as iterators. So In this particular case, it's input iterators. This is the weakest kind of iterators, but I think completely appropriate for this type of interface because in virtually every interface, what you're doing is just stepping through the results one at a time. So you can only go forward and you only have access to the current result. So the big enabler here, I think, the big win is that now you can use this with range-based for, just like that. And here's an example. So I'm creating a database. I immediately get the rows from this query, and I go straight into a range-based for loop, and it just works. And so this is, I think, matching most closely what you would expect from an interface and C++ in terms of matching features. It makes it really easy to use in the way that you'd expect. So, in fact, it's even better than that because I think if you've seen some talks by STL, he recommends it with range-based for that you do auto-ref because in many cases, if you don't do that, you've got an expensive copy that you may be able to avoid if the container you're iterating over is actually returning references. This interface uses proxies. So what's returned from a row set is actually a proxy object, and that's going to create a few issues, but for range-based for, this actually is a win. So if you do the thing which you're probably most likely to do, which is not auto-ref, just plain auto, it's fine. Since it's a proxy, it doesn't matter if it's copied. Or you can just take the device and use auto-ref, also fine. And of course, taking just a single reference, either constant or non-constant, doesn't make sense in this context, which is totally fine. There was a proposal by STL to actually eliminate the auto altogether, and that was discussed, but I think that's going to come back at some point in a different form, and that would also be nice here. So you may be asking yourself, well, okay, iterators are great, but how much overhead is that going to add to the cost of the interface? And because these are input iterators, it's actually not that bad. Now, this has been a subject of discussion, as we'll see, but it's really pretty light for input iterators. And you can see right here, there's a runtime cost to doing this because you don't know which iterator you're going to get in which order, and these checks have to be done in runtime, but it's not as bad as, say, with forward iterators. So this, to me, is okay. I don't think it actually matters that much compared to the other costs that you are likely to incur overall in a database driver. So what else can we do with this iterator design? Well, here's an example of a standard library algorithm, just in this case, find if. And you'll see here, there's a typo, it should say RNG. I'm getting a range from the query, and I'm passing it to find if, and it just works. So this example is looking for a key within the result set and returns an iterator to that row on the first one it finds. So this works exactly like you would expect, except now we're doing it in the context of database code. So we're able to leverage standard algorithms, which I think is just great. Here's another example. This one just happens to be with accumulate. If you say you want to accumulate a score on the client side, you can use accumulate. Now, this is probably something that databases do really well with aggregation, but for the purpose of showing another algorithm that would work here, this is it. So there still are issues with iterators that need to be considered, and it's not so much with the input iterator, but there are use cases in this design for other types of row sets, in particular stronger sets like full random access row sets. So you can imagine maybe you want to read in the entire row set instead of just having to buffer it for each time. And we're going to talk about that optimization, but this is something if in more complex types of iterator models, the iterator issues really start to show. So the answer to this is ranges, and I I assume that you've all probably heard of the range proposal by Erik Smith, but this is really a phenomenal piece of work. I think it's really impactful for the way we're going to write code in the future, even though I think it's quite a ways away. It's usable now, and I just think it really affects, I think, how this interface can work with a standard library. So I definitely recommend checking it out. It basically addresses the existing issues with iterators, particularly with composability, and brings a whole class of functionality, and I'll show you an example of that. So just to give you a sense for how this would work with that proposal, a ROWSET is an input range. And so a ROWSET, there's a couple concepts in that standard which define classes of access for whatever you're particularly working with. And the way it maps here is an iterable concept is simply anything where begin and end is defined. It turns out that I don't actually need to expose that in isolation because ROWSET is both an iterable and a range. So if you think of a range object, which in this case is the ROWSET, has a begin and end so that it works with range base 4. It's also lightweight in that copying is cheap. It doesn't own the elements, and it's default constructible, copyable, signable, and destructible. So it actually serves both of those purposes, which also further simplifies the use of the API. And then on top of that, if you think of these stacking, it's also an input range. So it does map perfectly into that proposal's notion of concepts and how it works. So based upon that proposal, how would things change? And the first thing I want to show you is an optimization. So the first operator compare, this is for iterators within ROWSET. The first one is the one we had before. And you can see it has a certain complexity. If you're using ranges, then it collapses to the one below. So that's a little bit more efficient. The reason it's able to do that is because it knows at compile time how to compare the iterators. And the key thing, which I didn't mention here, is that the key thing within ranges is that a begin and end iterator are not required to have the same type. In fact, if they have different types, it allows a compiler to see in the code that you're trying to compare an iterator to an end condition, and that eliminates branches in the code and simplifies the comparison. So you get some improvement from there, but that's, I think, really maybe the minor benefit in this case. A little bit better benefit is that with the composability. So everywhere where you would pass a begin and end, you can now pass just a single range object, which in this case is just the ROWSET. So what I did in this case is I just put it inline. You don't have to do that, but it does allow you to do that and makes the code a little more succinct. And you can compose the expression as the argument. So that improves the use of the existing algorithms. Now, I think the big win for ranges is in what's called range adapters. And I'm really excited about this. This is an example of a range adapter in the ranges library. And what it's doing is it's filtering the database result. But the way it's doing it is it's fetching the results lazily. So if you can imagine here, it's similar to CopyF if you have used that. What you're doing here is you're creating a filter and you're specifying the input range that you want to filter on and then a condition and a lambda. In this case, the example I'm giving here is you're looking for all results that have a minimum score. So it's a fairly straightforward example. This code is written, isn't actually doing anything. The only thing it's doing is creating a new range which is going to perform that result. So all you're doing here is setting up the ability to do query, and then when you actually access the range itself, then it executes the query, and then it fetches the elements one at a time. This is able to do something that you can't do with the it's not just that it's doing it lazily, it actually works. So if you tried to do this with CopyIf, what you would find is that it would not work. And the reason is because CopyIf is going to iterate through the results and input ranges it's going to exhaust the results. So if you were to try and access those copied results later, you'd have a bunch of proxy objects which were invalid. But if you do it lazily, it works perfectly fine. So this is actually doing something that really isn't possible with this before, and you're getting a lot of composability benefits. So I think this is just a huge addition to the standard library, and I think it works really great with this type of interface for databases. So just moving along to some of the other objects. The row object is simply a way to access fields within the row. So you dereference a row set, you get a row proxy. The row proxy then can be dereferenced to get a field object. And you can do it by position, you can do it by name, or you can do it by column, which column is another object that comes from the column's metadata object available at the row set. And then there's the field object. The field object is another proxy, and its primary role is to handle conversions. So if all you did is you just wanted to send it a standard out, that should be fine. If you wanted to do a conversion to a particular type, you can specify it via as template type T. And all of those conversions are handled within this layer. And also it has to handle the case where the way it was bound by default in the layer may or may not be the type that you're asking for. So all of those have to be accounted for. You should be able to ask for a variant, and you should have support for optional. And the interesting thing here is that the accessors that are listed above have the possibility of throwing. And that's because of this notion of null. So the value that you get back, depending upon the database, there's a possibility it may be null. So you cannot marshal into a type that doesn't inherently support nullness if the value is actually null. So if you use the accessors below, such as variant and optional, those are okay. Those do not throw, and it just means that if the actual field value is null, you will get that null reflected in the variant and optional. So that's a nice convenience to have. A couple other accessors you can test up front whether it is null. The name and the type are available at the field level, even though that's metadata that you would normally get from the column. It's very convenient to have them at the field so that you don't have to work with multiple objects if you really don't have a need to. So let me talk about field index a little bit more. So when you ask for a field by name, this isn't the most efficient approach, and that's because you're having to take a string and compare it to the names of the column and then return the field. If you use a numeric index, it's a little bit more efficient, but that's not as maintainable. So what can you do about this? Well, you can set up code like this, which is if you create index objects ahead of the loop, say ID, IDX, name IDX, what you're doing is you're looking up the indexes outside of the loop. And then when you get into the loop, then you can use these integer variables to index the fields out of that. And that is more efficient. It's harder to maintain. Whether it actually matters may really depend upon just how critical performance is for your particular setup. But there may be a better way to do this. And this uses varied templates. And let me show you how this works. So here I'm getting a row set out of a database. And then what I'm doing is, I'm going to go back a slide because I'm out of order here. Here is an example of what I call into. So into is a varied template in which you pass in the variables that you want bound to based on the query. And this works when your query is just a single row and you just want to get these into variables with the least amount of work as possible. So you don't even necessarily want to set up the indexing even by name. If you have a query that's this short, which is 4 values, why not just put them right into the variables? And that's exactly what this does. So for single row queries, this is a great way to just achieve that without having to worry about indexing into the row object. And it turns out this also can be applied at the row proxy object as well. So if you can imagine that, this can extend beyond just a query that returns single rows. It can apply to actually ones with multiple rows. And it simply means that within your for loop itself, you say row into and the names of the variables. So here I've got an example where I have a query that may return more than one result. I have variables that I want to put that data into. Then I go into a for loop, and on the row object that I got from the row set, I can now say row into, and whatever variables I put in there, whatever type, the VariDAC template will pick those up and do the assignment. So it's flexible in that regard too. Other possibilities here is that you could use a range, you could put into range. So instead of putting them into variables, they could go into a range, an output range, or they could do that either vertically for the whole result set or by horizontally for a particular column. And there needs to be some work in figuring out how to disambiguate and what makes sense at what level so that you're getting what you expect, but that's also a possibility. I should mention serialization here, because I think this is a huge need in the standard to have this ability to be easily implemented. So what I mean by, and I think this is really this isn't something that has to be integrated into this framework. I think it actually sits above this framework. But the idea here is that if you have a row set and you have an object, you'd like to use some type of reflection-based mechanism to serialize it into your object. And there are many ways that you could do that with the syntax. This is something that other languages have and is considered just commonplace to be able to do this. So serialization not only just for data, it would be applied to lots of different contexts, but particularly here for databases as well as things like flat files, things you get over a network connection. So this is an area that I think really would benefit by reflection in the standard. Really small feature here is, in some cases you may want to have access to the underlying handle, the native handle of the driver that underlies your particular choice of database, and that's what this does. So for example, if you say connection.handle, you will get a void pointer to a MySQL handle. And that maybe that's useful for testing, maybe it's useful because you have legacy code in which you actually need to get that handle to hook it up to. The interface does provide that capability, but you have to be careful with this because realizing that this is escaping the shared pointer mechanism. So in this example here, I say db.connection.handle, because it's not returning a smart pointer, that will go out of scope and you'll have a lifetime fail on that MySQL pointer. So you have to be careful with that. Now I want to talk about a particular feature that most drivers offer, which is important, which is called output binding. So what this is that the binding mechanism is set up by the driver where internally you declare a buffer in which information coming from the database goes into this buffer. And that's all managed by this framework. You don't have to ever deal with that. It's never exposed at the user level. There's something called array output binding, which is an optimization many drivers offer. And the way it works is that you specify an array, the size of the array that you want to allocate for the results to go into. So I'm going to explain how this works. So let's say you have a 1,000-row table. If you did not specify output array binding, what you would get is a buffer to hold just one row. If you do specify it, then what's going to happen is it's going to fetch, whatever size you declare each time it talks to the database. So you can imagine this is going to have some performance benefit depending on your use case. So for example, here's a case without any binding here, and I've just measured this for a particular database at 203 milliseconds. And I'm reading this 1,000-row table, and I'm just fetching over the results and adding them. So now I'm going to specify a row array size of 100. And you can see right here that it goes from 203 to 32 milliseconds. Now that's 100 rows for a 1,000-row table. So if 100 is good, maybe increasing it will be better. So let's set it to 500. Now it goes down to 2 milliseconds. And now let's just specify at the full size I want 1,000 rows, which covers the size of that table. Now, unfortunately, that number there was not updated, but it's something like 500 microseconds instead of that 2 milliseconds. But this is essentially 400 times faster than the first case without array binding. And I graphed this here of the 4 data points, and just to illustrate that how much of a performance increase this is, that's a log scale right there. It's orders of magnitude faster to do this. It may even make sense to just create a default in certain circumstances. And in fact, row array size could be set at the database level so that you can ensure within your application that all of your connections have some type of default row set size. Now maybe this does cost memory, but I think there's a certain number in which it makes sense for probably every application to have this. So that is a pretty dramatic improvement. And all of this, you get all of this without having to affect user code just by specifying the row array size. On top of that, some drivers also support this notion of, I'll call continuous array binding, where you can say, normally when you specify these column arrays, they're separately allocated, but some database drivers allow you to actually overlay those arrays into the same contiguous memory. And so what you end up with is your entire result set in contiguous memory. And so if what you're going to do is fetch data from your database and you're going to spend some time with it processing it, then this could be an added improvement because you can get the entire result along with all the columns in contiguous memory. So this is another opportunity for improving performance. Detached row sets. So the row sets we've talked about up to now are just forward only, or they are input only, 1 row at a time. But here's a notion where you can ask for detached rows. And when you do this, you get a row set that is random access. So what's happening here is if you have the ability to just get the row set all at once, and you can see from the previous slides that this has a real benefit because of the performance, then you have some added abilities that come with this. And here again, this is why I mentioned earlier why ranges plays into this, because now you have a row set that may benefit quite a bit more from the capabilities that ranges provides. This detachable row set also can outlive the other resources. So if you want to take this detachable row set and just hand back the connection, it automatically releases the connection, all the other resources associated with it. You can keep it within your application in essentially a long state. And what this does is it enables caching. So for example, you can imagine that if you have a database application and you want to store small tables locally, this is something that will help do that. So just on the same notion, I want to revisit input binding, which was mentioned before. Just as output binding really benefits from array, the same can be done for input binding. Input binding is where you're specifying with execute variables that are going to go into a statement, such as insert, with no results coming back. You can do array input binding with many drivers, and it's the same pattern where you say how large do you want that buffer to be. This also is a huge performance win. So you can imagine the only downside of this is that as you're inserting information, none of those are being pushed to the database until you reach the size of the buffer. So if you have an application where you're not having to transact a row at a time, you're just trying to stream data into a database as fast as possible, then this makes a lot of sense. And every time you fill the buffer, it's going to flush out to the database and then keep writing them locally. Just a note about type conversion, which I said before. The field object has to deal with a lot of type conversion details in terms of how the data was bound internally and what it is that's being requested. And depending on how those match up, there may or may not be a cost associated with that. And there's ways to control that. If you know that you're always pulling things out of strings, you say, bind everything natively internally as strings so that there's no conversion on this end. A little bit about policies. So this design is a template-based design. And that does facilitate the ability to control certain parameters about how things can be controlled at compile time. Things like custom allocators, connection pooling, things like resource resolvers. There are other possibilities that I think may be possible as well here, such as if you really don't want the cost of shared pointer, you could specify just make it scoped. That's possible here. I want to talk a little bit about a utility example here. By that I mean here's something that you can use on top of this interface, which is an interesting use case. So here you may have experienced this issue before where databases aren't actually particularly good at returning hierarchical results. So if you can imagine you have an inventory and an orders and a parts table, you end up in a situation where you're having to redundantly have column values because all of this has to be flattened in the result set that comes back. And part of what this does is address that problem, and the other thing it does is try to achieve it with high performance. So, this example, what it's doing is it's opening a connection, 3 connections database, and it's streaming simple select results on these 3 connections back to your client. And I'll call it, it's like a client-side join. You take the results coming back from each of these tables, and you do the join on the client side. And I'll call it a natural join because the idea here is, just for simplicity's sake, just infer how to join this from the keys within there. So the ID matches from one table to the other. And there are a few caveats to this approach. The overlapping keys have to be ordered in the right way so that as these streams have to be ordered together. And what's happening is it's much like a merge algorithm in the standard library, is that it's reading the values from each of these streams and joining them up, and the cost is really almost nothing. And if you do this, there's no space taken up by it, and it scales quite well, and it solves the problem of having to deal with redundant data. So this can actually be made to scale quite large. It's something you'll notice that when you get into very large databases, even trying to pull things out by index becomes expensive. If you have a database that supports index organized tables or clustered indexes, this can scale to many hundreds of millions of records. So this is a simple utility that can be, because the interface is using iterators, using a container-like approach, it's relatively easy to do these kinds of higher level algorithms on that. There are other possibilities for join algorithms. More general examples, including instead of a natural join, you could say just have an ordered join, which takes into account maybe column conditions specific to what you're trying to join. And the other one mentioned before, which is a much more general type of join. If you have a cache result set, possibly from other databases than the one you're querying on, and you want the benefit of joining with that because it's resident, that can be built on top of this interface. Mention quickly here that I've been showing examples of a direct interface, which I think most of the time is what you want, but sometimes people want to have a polymorphic interface because their application has to talk to multiple databases, and that's what this does. You can say at runtime, I want to have a different database on the connection, and it will give you that. And the way this is designed is completely transparent to the drivers. So for instance, if you implement a driver for a particular database, it's available in this poly interface. And this is all done through type erasure. Basically, the interface for the driver, if you specify standard database, create database, you are asking for the poly driver, and this is something that could potentially be in the standard because it's not specific to any database. You get it for free. If you want to look like what it would be like to add drivers, this is what it would look like. You just register them based on the type. So you can say, I want to register all 4 databases, and by doing that in your code, you can now ask for connections on any of those 4. I have a reference information implementation test suite, which I won't talk about too much due to time. But needless to say, this kind of a project needs lots of time spent on running through all kinds of use cases. So I've spent some time trying to build out a test suite that's going to cover all of these and verify that they run for every driver, not only direct mode, but also polymorphic mode. So just briefly, I'll talk a little bit about the implementation detail, not all of them. But as I mentioned before, there's a front end and there's a driver layer. And the front end takes care of all of the reference counting. None of that is exposed to the user. Defines all the interface functions, including redundant ones that you'd like for convenience. Manages state, manages connection pooling. None of that is done at the driver layer. So I see this type of a design as a big win. Otherwise, it would have forced all kinds of complexity on the driver layer that you don't necessarily want. Now, technically, you wouldn't have to use this mechanism. It is a layer on top of that. If you wanted to just implement a driver to spec, you could do this. But I see this as a big win for driver implementation, at least for the reference implementation. Driver interface, the nice thing about that drops out of this is that it not only is the driver interface fairly simple and familiar once you have certain template definitions. You'll see at the bottom here, the things which you must implement in this driver to work with the front end is really the same layers that you have in the front end. Database, connection, statement, and result. And you don't really have to manage any resources. The resources that you need, for instance, having to pass parent object to child object is all handled by the front end, as it's seen here. Now I'm going to talk a little bit, just briefly, about a challenge, although I'm running out of time. This is an implementation detail. This is about polymorphic execution. And one of the things that is challenging about this implementation is that you have to pass, this is the case where you're preparing a statement and you're passing arguments repeatedly, and that must go through a variadic function on the front end. But what it has to do, if it's a polymorphic driver, is take those and call them with a variadic function in the driver at runtime. So I'm thinking, just because it was so motivating to take all of that work out of the driver layer, maybe I can take at runtime that information, repackage it, and call the driver layer's variadic function without having to put any additional complexity in the driver layer. There are two challenges: that unpacking variant arguments, and second, needing to transport arguments from one variadic template to another. And this is what it looks like. I think that this is unusual because what you have to realize is that you're taking something at runtime and you're trying to form a variadic call. That's a really unusual thing to do. You're going upstream. So you're taking a vector of variance and you're saying, I want to package that into an actual fixed argument call. And that's what this diagram represents. And then what I'm going to do is I'm going to unpack the variance, and then I'm going to call the driver's execute. And then the driver doesn't know whether it came from polymorphic driver or not. Seems okay. Is this a good idea? So this is what happens when you do this. Is the reason this took 2 minutes to compile, and I'm thinking, okay, why is this? So what's happening here is this is most definitely a fail, but it's also kind of awesome to think about what it's doing. If you can imagine that you have a variable number of arguments taken from 10 types, and you're going to support it up to 5 arguments. You are asking the compiler to generate over 30,000 functions. The fact that this works at all is actually kind of interesting. Now, if it hadn't taken so long to compile, I might have thought, this is great, look what I did. But because it took so long, that was a tip-off that, well, maybe this is generating far too much code. But I have to wonder just how much code is too much. I mean, if it really is performing work in the modern age, maybe, this seems excessive to me. But the point is that the impact of this is not that great. It simply means that your driver must support a second call with either a vector variance or your variadic argument must support variance. So it's a little, just a tiny bit more complexity in the driver, and that's probably the right call. Although I did learn in STL's talk that the approach of peeling off arguments in a variadic template is a horrible way to implement it. So I would like to at least try it for a better approach using parameter packs and see if that maybe drastically reduces the compile time. There's a lot of future work here in this project, and one of the big things that should be of interest to everybody is to have non-blocking functionality. This isn't feasible with every driver, but some drivers do provide this, and what's needed is for the underlying driver to support non-blocking I/O. There's one in particular that I have my sights on, which is a project called WebScale SQL, which is a project out of Facebook and a couple other companies, and that project offers a MySQL compatible driver with the additional non-blocking calls. So if you have a project built upon that, you can literally use the driver out of this project and use it against your existing MySQL database. And I see this as the first driver with full support for this to make this work. I believe Postgres can also do this as well. Reference implementation roadmap. There is the current support here is for MySQL and SQLite, although these phase 2 databases should appear very quickly. I do have this project on GitHub, although there's no code checked in. It will be checked in as soon as I clean it up a little bit. But phase 1 and phase 2 do actually work pretty well. Now there's a notion between having sort of a shallow support for all these databases and having deep support. For instance, are you supporting things like blobs and very specific types of columns? That's going to take some time to fill out. But in terms of being able to run a growing test suite that's including basic things like selecting stuff out, I think that that's pretty achievable. So, and then phase 3 is to start thinking about asynchronous designs and support other databases. And that's it. Any questions?
My company has been doing quite similar work for maybe 2 years now. You might have seen our poster downstairs. And one of the things we run across every time is that we have to support multiple databases. And when you do that, we discovered that polymorphic is not enough because the SQL itself is not standard across vendors. So I was wondering if you thought about that and if you had something to handle that problem.
So the question was about the fact that SQL is different among different databases, and did you say it was? I'm not sure if you're talking about the binding types, but I would say that this particular layer is actually not concerned with differences in SQL for the most part. In fact, things like the binding syntax is question mark in MySQL and is colon field in another database, and this layer is agnostic to that for the most part, maybe entirely. It really matters for higher level code, like if you're trying to do an ORM framework, there's absolutely a consideration. But because I'm trying to focus on the foundation, that's not something I largely see as having to handle. There are some details there, but I think, was that your example? Is that, I think if I recall correctly, you are looking at higher level constructs for how you can...
No, we haven't have to write code that will work on any supported database without doing a if Oracle something, else if MySQL something,
Yeah, that's much more ambitious, and this is just providing the foundational work for you to build that kind of an ORM or Hibernate-like facility. I think that's definitely an interesting thing to do, but that's not necessarily what we're trying to do here.
Interesting presentation, thank you. Can you go back to the slide that shows the papers you've read or referenced? I'd like to just get a picture of that if I could, thank you.
Right. So first of all, I think it's great to see that several people are now trying to get databases into the standard again. That's been dead for quite some time. So thank you for that. I'm not sure if string-based approaches are the thing for the standard, but that's a different question. Certainly not enough time for this here. I'm interested in connecting your library to SQL++11. One feature in SQL++11 is that it can change syntax things, as mentioned before, depending on which database is actually used. Does your database have this information at compile time available for a layer like SQL++11?
I'm sure it could. I just probably I need to understand the specifics of what you need. I mean, if you're
well, the thing is, does the code know, or the compiler know at compile time that, hey, this is an MySQL database, for instance? So
I think it could. I mean, the question is how to implement that. I mean, it's, you know, I can think of a tagged type mechanism, but I have to be careful about what I specifically put in in code that might be a candidate at some point in the future for standardization, because nothing in the standardization can refer to any particular, like say, enumerations or tags.
Yeah, sure.
Maybe it can be I don't know if it can really be a string and be compile time, but I think it's definitely doable one way or another. So we should definitely talk afterwards and see. And I'd like to understand. And by the way, this is my sort of notion after years of hand-rolling database interfaces and looking at various projects and just experience about what is sensible to me. Once I think this is on GitHub and people become interested, I'm really interested to see what the community thinks of this interface. And I might expect it to change quite a bit over time based on a larger group of people trying it and finding what works and what doesn't. So I really, if you have any kind of effort or interest in working on this project, please talk to me. So yeah, I think that I would like to talk to you further about that.
Okay.
Hi, a couple of simple questions. What is the licensing level of the library that's on GitHub?
Whatever is the most liberal. So I don't know if that's MIT. It's definitely this is a not. There's no attempt to commercialize this at all. Is going to be the most liberal license that works for everybody's use case.
Great. My second question is the code examples that you gave in the slides. Are they all examples of current functionality?
Not everything, but maybe 80%. I mean, there are some things, I think there are a couple slides where I had maybe some future capabilities that depend upon things appearing in the standard, but I would say that 89% is in the code. Once it's checked in, you will be able to do that. Now, there are probably some things, yeah, I would say that's reasonable. Now, there's certain kinds of, like I said before, rounding out all of the various support for types within the database is often a lot of work, just making sure that every type is supported and can be input bound, output bound. But yes, you should see nearly all that functionality available. And it may depend upon, of course, C++ 11 by minimum. I'm going to try and work my way backward from 17 because I suspect that there will be people interested who want to use framework in 14 or 11, and I can probably just reduce some features if they're not supported. So yes.
Are there sample programs we can download?
There will be. I mean, the intention is I'll put lots of examples on the GitHub page, and you'll be able to see a lot by looking at the test framework. So, by the way, this is a header-only library, and part of the reason for that is it forces me not to have to choose one of 20 build tools, including my own I'd like to write. So by doing a header-only, you should be able to just check it out and actually drop it in as a clued path, and it should work. Except for the test suite, that might require a slight build. But it should be, I do want it to be extremely convenient to use, even to the extent if I can put it on Brew to just make it really just quite simple to use, I would be happy.
Thank you very much.
Sometimes results from SQL statements are returned in chunks to the calling program. Would there be iterators that are smart enough to let you go through a whole returned data set and so that it would hide the fact that it's actually being returned in chunks?
That's exactly what output binding does for you. So, that a lot of times when you look at a database API, it shows you as a user how to achieve that. And at some point in rolling databases, I realized that could be hidden from the user. So just when you specify an array binding size, internally it's going to allocate a buffer for a certain amount of size. And when you are fetching row by row, you're not round tripping in the database, you're only round tripping when that buffer needs to be refreshed. So did I answer your question?
Yeah.
So hopefully you get all those benefits without having to do anything in the user code, just by specifying an output buffer.
Thank you.
Thank you.